Good afternoon, class. Today what I'd like to do is to go over a type of problem that you will encounter when dealing with gravity. This is a different type of problem because in horizontal motion, direction is important, whether you're going this way or this way. It's important, but it's not super important because you can actually declare one way positive or the other way positive, and it won't matter. However, with gravity, nature decides which way is gravity points, not you. So you can't say this way is positive or this way is negative. Nature will always tell you gravity will point this way, and which we of course define as down, and the opposite of that is up. But which one of those is positive? In this video and the next video, I'm going to use this exact same problem, but I'm going to change one thing, which is this, the direction which is positive. So in this example, gravity and down, the way gravity points is positive. In this case, the math will come out a certain way. If I declare up to be positive, gravity will point the opposite way, and you'll see how that changes between these two videos. So let's go over the problem, starting off again in red, just like we always do with word problems. So a ball is dropped off of a cliff from rest. If it falls for 3 seconds, how tall is the cliff? Oh wait, how tall is the cliff? The last sentence is very important, so pay attention. It says, you are on Earth. That is an assumption. I may not always write you are on Earth, but if you ever see it, or if you don't see anything like you are on Earth or anything like that, you may assume you are always on Earth. I will tell you otherwise. Like for example, I might tell you you are on Jupiter, you are on the sun, and then you would have to base your answer differently depending on where I tell you. But if I don't say anything, you are on Earth. Okay, so in this case, how do we do this? And you may have noticed a couple of differences between my how to solve physics problems, which is there's a picture here. And this picture is going to be important, especially from here on out, because the picture will determine where you go, what is positive, and it helps to focus your thinking. So there are a couple of key words here. Everything you need from this problem to put into this form with all our green numbers is actually written in this problem, but it's a little bit subtle, and you have to know the vocabulary in order to kind of tease out the actual numbers. So that's why I wanted to make sure I point that out and keep it on a video so that you can see it and always remember it and refer to it, even in future problems. So the key words are, and I'll start from the top, a ball is dropped off of a cliff from rest. Every time you see this word rest, this is super important. Rest means that your initial velocity is 0. And so that's why over here I wrote my initial velocity is 0 meters per second because of the word rest. The next one is obvious. The ball falls for 3 seconds, so obviously I'm going to write that in there. But now you might be wondering, why is the acceleration due to gravity equal to 9.8? Where did this number come from? Well, that number came from the assumption that you are on Earth. And on Earth, the acceleration due to gravity is 9.8 meters per second squared. That is simply a fact that you can search up, keep it in the back of your mind, and then you can use it from now on. So now here, this one right here, this y initial, where did this 0 come from? Because that definitely was not mentioned in any of the words of the problem. This is where I would like to point out that physics does grant you one superpower alone, and unfortunately it is, enjoy it while you can, because this is really the only superpower you get. And that superpower is to determine where the starting point is. Is the starting point going to be here on the ground, or is it going to be where the ball starts to its fall from? So that's what you have to be looking for whenever you're starting a problem, because where you start the problem will actually determine how you approach it. So that's why a lot of times a picture is very important. So in this case, what I decided to do, because down is positive, I decided to make the top of the cliff where the ball is 0. And it's going to fall in the positive direction towards the ground. Now obviously this will change a little bit because in the next video, when I do make up positive. So be on the lookout for those little bits of difference right there. Okay, so that's what this picture shows. It has a ball of mass m falling in this direction. That's this arrow. It's being accelerated by the acceleration due to gravity, which we have a shorthand of g, lowercase g. I have the cliff, my crude drawing of a cliff with its height y. And from there, I will determine everything else that I need. I've gotten from the problem itself, I've gotten all my green number information that I can just stick in. Of course, I've got in blue my equation, which is fine, which is normal, just like we did in the other videos. And so now what I'm going to do is I'm going to use the shortcut method, which means I'm not going to put in all of the units and do unit calculations in this one, because I'm just trying to get the point across that I want to solve this problem. The main point is how to extract the information that you need from the words to this form, to the equation form. So here we go. I've got my equation y equals y initial plus v initial t plus 1/2 a sub y t squared. Equation 2 on the kinematic equations, just in case you need a refresher on that. So I take my equation and I plug in my values. So y initial is going to be 0, v initial is going to be 0, times 3, which is the time, plus 1/2 times acceleration in the y direction, which is 9.8, times the time again, 3. Don't forget, this time is squared. Next, I'm going to ignore the zeros because 0 is plus 0 is still 0. So I'm not going to write them again, but I'm going to take the time to work on these parts over here. So 1/2 times 9.8 is 4.9. And of course, 3 squared is 9. Now is the part where you pull out your calculator, because 4.9 times 9 is 44.1 meters. Now, normally, in the other problems, you would be done. However, because this is gravity and there is a little bit of a difference, and you'll see why I ended this way in the next video, especially as a compare and contrast to this. But it is important that you answer the question with a sentence. That way it is crystal clear what the answer is, because sometimes you'll get an answer and it may not make intuitive sense, and so that's why, and I'll show you that in the next video, but that's why I said that the cliff is 44.1 meters tall. So that is how to take this kind of a question, turn it into the type of physics equation where you can just plug and chug, and then plug and chug, substitute, solve, and then get your answer. That the only real differences between the first kinematic equation and this second kinematic equation is that I'm drawing a picture here and that I'm answering the question with a sentence. This is very typical of physics problems, as you will see from now on, mostly because these problems get a little bit harder to just describe, and there's a lot of vocabulary that you're going to need to understand, and so that's why drawing pictures will really help you out. So that is how to do a problem with dealing with gravity. Good luck on your studies. May the force be with you.